Okay, so our next set of notes are going to be on solving using multiplicative inverse. A lot of people get confused about what multiplicative inverse is just because it sounds complicated. But all this means is the opposite of multiply is divide, and the opposite of divide is multiply. So multiplication given in an equation is going to need to be undone like to get rid of it, to undo it by division, and vice versa. So if I have a division problem and I need to get rid of that, I would use multiplication. So these two are our inverses, multiplying and dividing. What we're going to do is take a look at some basic examples. These are the easier ones, and then we're going to move into some more complicated stuff. But again, we need to make sure that all of our skills are on tight so we can do well. So we're going to take a look at a few examples from the book. So this is from page 136, and we are going to start with a very, very smart number 1. So number 1 in the book says 6x equals 36. Now, the operation between the 6 and the x is multiplication, and I know that because there's no other sign there. There's no plus, there's no minus, there's no fraction. So when there's a number right next to a variable, that indicates multiplication. Now, I need to get x by itself, and in order for me to solve for x, I have to get rid of the 6 by dividing. But I don't use a line dot dot like on a calculator. I show division by using a fraction bar. So I'm going to divide by 6 like this. I'm going to divide by 6 like this, because whatever we do the left side equals, we have to do the right side. 6 divided by 6 cancel. They really become 1, and 1 times x is x, and that's why it's called a multiplicative inverse, because when you multiply and divide, the outcome is 1 whole. Okay, it doesn't make 0, it makes 1. And then 36 divided by 6 is just 6, and there's your answer. The next example that I wanted to do with you was number 5. This is right out of the textbook. 84 equals 7x. Now, why I picked number 5 was because the x is on the right side of equals. We're still trying to get x by itself. There's still a 7 here, and the 7 is being multiplied by that x. So to get rid of the 7, we got to do the opposite of multiply, which is divide. So we're going to divide both sides by 7. Now, if you're uncomfortable with knowing what 84 divided by 7 is, if you can't do that in your head, estimate. 10 times 7 is 70. So it's got to be more than 70. Well, how much more is 84 than 70? Oh, 14. That's 7 times 2. So instead of it being 10, it's really 12. So x equals 12 in this case. The next example I want to show you is number 9. Number 9 looks a little tricky. Number 9 says -1 equals -z. Now, I don't know if you remember this, but when you don't have a number in front of a variable, there's really a invisible 1 there. So in this case, there isn't an invisible 1. There's an invisible -1. So we're trying to solve for z, and we have a -1 there. What we want to do is divide both sides by -1. Keep in mind that a negative divided by a negative is a positive, and 1 divided by 1 is just 1. So that cancels, and z is left at the bottom. -1 divided by -1 is +1. And there's my answer. The last example that we're going to look at for multiplicative inverse is number 12. And number 12 says 8x equals -56. So if you notice, 8 is being multiplied by x, so to undo it, that multiplicative inverse, we're going to divide both sides by 8. The 8 divided by 8 cancels and gives you 1. 1 times x is x. And -56 divided by 8 is -7. So you got to pay attention to those signs too. Okay? So this is the basic part of solving using multiplicative inverse, you're going to go do your practice questions. There's 3 of them for you to do, and then you'll progress forward. Contact me if you have any questions.